Okay, so we're going to end the first day of week 6 by talking about energy expenditure. Here are the 4 objectives for the day, or for the lecture. So, basal metabolic rate. Now, when we talk about metabolic rate, we're just talking about how much energy is your body actually using and at what rate is it using it. Okay, so oftentimes we'll do kilocalories per day. So we could get into a formula. So how much oxygen do you use a day times the average number of calories used per liter of oxygen. Really difficult to measure because, well, one, there's no way to know how much oxygen you're using a day unless you're breathing on a mouthpiece all day, which would be terrible. But we can get an idea, right? And so this leads to something called the basal metabolic rate. And so the basal metabolic rate is how much energy would you be using at rest while you're supine after 8 hours of sleep? Okay, or another way to put this is how much energy, what is the bare minimum you need to survive? Okay, so what are the metabolic rates affected by all sorts of factors? All right, so your body composition. So if you've got more fat-free mass, in other words, you've got more lean muscle, you burn more calories just to take care of that muscle. So there you go. More muscle, more calories. Body surface area. If you've got a larger body surface area, you're going to lose more heat. If you're going to use more heat, you're going to need more calories to maintain your body temperature. You're going to use more calories. Okay? Age. This is where it starts to go downhill a little bit. As you are older, you use fewer calories. It's just one of those things that happens. This is why we put on weight, or why people put on weight as they age. So in other words, aging sucks. Okay? Unfortunately, the incidence of aging is 100% in the general population. Core temperature. Okay, core temperature leads to more calories being used because if we have a higher core temperature, chemical reactions are occurring more frequently. That allows us to use more energy. And then finally, stress. The more stressed out you are, the more calories you use. So if you're having a stress response, then you're going to get rid of, or you're going to have a higher metabolic rate. So I guess there is a benefit to finals. All right, so basal metabolic rate is just kind of difficult to measure, kind of annoying. And so what we have instead, or what we tend to use, is something called resting metabolic rate. Okay, and this is generally within 5 to 10% of basal metabolic rate. It will always be greater than. Okay, remember, basal metabolic rate is the bare minimum. Resting metabolic rate is just what are you using at rest. Okay, so typical adult has a resting metabolic rate of anywhere between 1,200 to 2,400 calories. But, and this will blow your mind, is that so the average, so that's the resting metabolic rate. So when you're at rest. When we're talking about metabolic rate, that's what are you using throughout the day. All right. And notice that this goes up by 600. So 600 calories a day is what a typical person might use for exercise. But what's insane, this is the crazy part, is there are some athletes that exceed 10,000 calories. Now we're here in the land of the Colts, and well, I'm not a Colts fan. I do watch ESPN every once in a while, and most of the Colts fans, especially if you remember when Peyton was playing, you know who Jeff Saturday is, okay? And if you didn't, he was the center during the years that the Colts were pretty good. And he was a large individual. Well, if you look at him now, he does not look so large anymore, okay? And many of these athletes, especially football players, they go one of two ways after they stop playing. They either drop a ton of weight or they gain a ton of weight. Because one of two things happens. One, either they just continually keep eating as they've been eating, and now they're not exercising as much, so they just put on a whole bunch of weight, or they don't eat as much and they lose the weight. And what I've heard in interviews with some of these, especially these offensive linemen, is just they were either practicing eating or sleeping or playing. Like that was their life, okay? But once they stopped playing football, they didn't need the weight, and so they could stop eating, and so it's why they drop weight, or they can drop weight really fast. But 10,000 calories a day, like that's crazy. All right, so how does metabolic rate play into submaximal exercise? Well, anything that you do requires energy. So if you're active, so like you're doing exercise, that's going to increase the energy requirement. And it's nice to know that metabolism increases in proportionate in proportion with intensity. So as your intensity goes up, so does your metabolism or your energy requirement. And so ultimately, we can determine how much it costs or how many calories we use for a given intensity when someone reaches steady state. And remember, steady state, we have constant oxygen consumption, so we can measure this, having someone breathe on a mouthpiece while they're doing a treadmill test. It just takes a few minutes to get there. And we're going to explain later, in a couple of lectures later, why it takes some time to occur. So, when it comes to steady state and submaximal conditions, there are a few things that can kind of alter this a little bit. So we can, and we do, especially during intense exercise, experience something called metabolic acidosis, okay? And so this is because we're producing lots of hydrogen ion. That hydrogen ion gets in our bloodstream and we become acidic. Well, what happens is we start breathing more than we actually need. And so our VCO2, or the amount of CO2 that we're exhaling, is actually exceeding the amount that we're producing, and so we end up with a larger RER than what's actually occurring. Okay, maximal exercise results in this. Okay, now during non-steady state exercise, it takes a little while for that VO2 to catch up, and like I said, we'll talk about that later. Hyperventilation, which is what happens here, so I should order these differently, but let me get a pen here. Whoops, maybe. Okay, so two causes this one, and then 1 causes this one. Okay, so when we become acidotic, we start breathing more. In fact, we hyperventilate, so that causes us to have a larger than normal VCO2, and so it looks like our RER will be higher than what it actually is. If you don't have a good mix of nutrients in your diet, so let's say, for example, you're on a low-carb diet, then your RER is going to be off because you're relying on other substrates such as protein. So if any of these 5 conditions are occurring, RER doesn't give us a good estimate of RQ, which means we can't really estimate how much energy you're using. And especially with the ones that I've tried to highlight here, that's when RER exceeds 1. So this leads us to maximal oxygen uptake. So during graded or incremental exercise, so where we exercise at a certain intensity for a little while, and then we increase the intensity and we stay there for a couple minutes, and then we increase, so on and so forth, what we found is that as we increase the exercise intensity, VO2 goes up. This shouldn't be surprising. The harder the work, the more oxygen we need. Okay. And this is for subjects that are essentially the exact same, like height, weight, age, that sort of thing. So they're all controlled for, and or at least there's been adjustments made. Like we can look at VO2 in terms of body weight as well. But notice that we reach a plateau. All right. So once we reach a plateau, which means we're using the maximum amount of oxygen possible, we can increase the intensity, but VO2 remains constant. And the reason that this happens is we just don't have the ability to either get oxygen into the body, take oxygen out of the bloodstream, or use the oxygen that's in our cells any more than what our maximal capacity is. And so we can increase our intensity because we start relying on those anaerobic systems. Okay. And so VO2 max lets us know what's the maximum amount of oxygen a person can use. The last thing that we're going to talk about is absolute versus relative. And so we've got both scales here. We've got absolute, which is here. And so absolute is just how much oxygen are you using? I want it in terms of liters of oxygen. All right. And then we've got relative, which is this axis over here, which is how much oxygen are you using, but we're going to standardize it versus body weight. Okay. I believe I'm at probably the largest person or close to being one of the largest people in class. And just by that fact alone, I'm going to use more oxygen than anybody, regardless of my fitness. And so if we want to know who's truly the best aerobic athlete, then we need to have a way to standardize it. Okay. And so we do that by dividing our VO2 by body weight. So here are 4 things that I'm hoping you can do at the end of this lecture. And so, yeah, so 1 day down, 1 more to go.